Hello again, Tom from Every Step Calculus, everystepphysics.com. This is the partial fraction decomposition problem, but what I wanted to show you first was every one of these problems that I do in the calculator, which is thousands and thousands of them, I have to do the first problem on a piece of paper to find out how to do the integral and find out how to do everything and put it down and get it into a step-by-step situation so that I can program it, which I do then program it for you in the calculator. So my step-by-step paper that I've copied here on 13122, this is the program partial fraction 3a, open and close parentheses, tells the calculator to do the program. And you can see all that I do on here. First I get all the exact as best I can, made some mistakes here, but I clean them up and finally get the answer and check the answer on the internet and check whether it's cool with everything else. And then I program from here. So here's the problem at hand. We're going to go to the main menu. I'm already at partial fractions decomposition here. Index 8 you'd put into the entry line here. I'll show you that if I can get to it. So here's index 8. I'm going to clear the screen. F1 8, you clear the screen so it's clear here. F1 8, okay? So I tell you, when you buy my programs and download them to your computer, I tell you how to put index 8 in here, on here, and then you open and close parentheses, and then you can do the programs. So the first program comes up is the main menu. I'm already at partial fractions here to save some time, but you'd scroll to it with the cursor here in the P's, because most problems in your test will ask you that you do use substitution or integration by parts or whatever the test asks you to do for those problems, and shows you we're into the program. And then they're going to enter the integral here. And you enter the integral by pressing alpha. In any one of my programs, you have to press alpha first. So you press alpha, and then the left parentheses, and then the 7 times x, and just plus 5, and then the left parentheses. Now, to save time and to make sure that the calculator simulator here does not screw up, I have already programmed the problem into the entry line that you just saw. So this is what you've just entered in the entry line, okay? And then you check that and you see if it's all right. And if it's all right, you press OK. If it's not, you go press 2 and go back and change it. I say it's all right, so I can scroll to it here and press enter, or I can press number 1, the number before it. And of course I factor the denominator for you. One thing I wanted to say, that before you do any integral problem, what you first do when you have a fraction and you want to integrate it, first thing you do is see if you can't factor the denominator. If you can factor it, then you're into partial fraction decomposition. If you can't, then you need to check next whether it's use substitution. For instance, if this was in the denominator, the derivative of this one here, x squared, is 2x plus 2x dx, okay? And you see if you can match the numerator. Well, here's an x in the numerator, and here's a dx here, so if you saw this in the denominator, you'd know that probably is a use substitution problem. And of course this then becomes u. And then, but I'll show you that when it comes time. Those are just kind of hints for calculus right now. We're setting up partial fractions for this problem here. And in math, you have to do the same thing on the left side of an equation as you do on the right side. Well, we want to multiply the denominators on both sides to get rid of the denominators and just have linear equations here. So this times this, of course, equals 7x plus 5 on the left side. And then you have to know what you're doing with partial fraction. In other words, you see this, you have to put, this is going to have a over x, and then the x, anytime you see an x squared plus c, you know it's going to be a bx or plus c, or a cx plus c, or whatever. Okay, depending upon what you see here. So you have to kind of learn that point in partial fractions, okay? A singular entry here is ax. And the bx comes from x squared plus 4, bx plus c. But anyway, just write this down. This, if they asked you to set up the problem, this is exactly what you'd write down on your paper, and then you go on to the next problem. You know, got an A in this problem. Now, if they want you to, in a homework or something, keep going and figure out everything else, or finally get to the integrals, then you can stop whenever you need to on these programs, because I do it step by step for you. So when we eliminate the denominators, here's the equation: 7x plus c equals a x squared plus c plus b. Now we're going to expand the right side, so we multiply it out and come up with this. We combine the terms, a plus bx squared plus 4a plus cx, okay? Match coefficients of the left side. 5 equals, that was the only number on the left side, and this is the only number on the right side, 4a. But notice we can substitute, or not substitute, but do the math, and a is equal to 5/4, so we're dividing the left side by 4 to get the a. There's no x squared on the left side, so that has to be 0. So 0x squared is equal to a plus bx squared. Okay, so 0 is equal to a plus b, and so we sub in for a, and b is equal to minus 5/4. Cx is equal to 7x, so we're going to do 7x, so then c has got to equal to 7. So the original partials are here. Remember, just before we figured that out. And we sum in the values of a, b, and c right here. Now we do the integration. So we set up the integrals, 5/4 over x dx, etc., etc. Here's minus 5/4 x over x squared plus 4, and 7 over x squared plus 4. We integrate the first one. This is just a regular log rule integration for in this problem. Anytime you have a singular thing in the denominator, it's always going to be a log of x, and then the constant goes out in front. Here's a problem here. We have the constant inside the integral. We take that out first. It is used substitution because I told you at the beginning to really check this out, and in the denominator, if there's x squared plus 2, you do the quick differentiation of this, you know, and that's 2x plus dx, not 2x plus 2x times dx. I show you that. So we bring the constant out, and then we have u x squared plus 4, which is u, and du is equal to 2x dx, and then 2 divided by 2 separates the x and dx. Well, here's dx here, and here's x, so we, in the numerator, so we've been able to eliminate that and change it to du over 2. So we rewrite it and substitute u, so we come up with this here, minus 5/8 times the integral to 1 over u. Now here's the singular thing in the denominator, so it's going to be a log rule again for now. It's going to be 5/8 times log of u plus c. I show you that here. We back sub, you know, for the u, of course. Make sure you finish the problem off like that. And here's third, 7 over x squared plus 4. Well, somehow you have to have an epiphany or some dream or something and figure out whether this is an integration rule. This is not a... It took me a while to find this too and how to do this problem, so I had to go to the calculus book, and it's buried in there somewhere, you know, and you're supposed to memorize this for a test, but generally the professor would have you do one of these problems so that you know it's an integration rule for this type of integral. So, constant out of the integral, and then here's the rule. 1 over a squared plus u squared du is going to equal to 1 over a arctangent of u over a plus c. Well, now what is u and a? Well, I show you that. X squared is 4, a is 2, u squared x squared, u is x. And then we substitute in. When we substitute in, we get 7/2 arctangent of x over 2 plus c. So here's the original integral, and the answer is this right here, all of this, okay? Pretty neat, huh? everystepcalculus.com. Go to my site, buy my programs. You can call me on the phone. I'll help you with calculus, whatever as I'm capable of doing. Of course, a lot of people might call at one time or whatever. And I'll get back with you, though, don't worry. And I'll show you how to do my programs, or else I'll show you how to do the actual calculus problems, you know, if you need help with calculus. Certainly know about this stuff after all these years. So think about buying my programs and loading them, and keep your calculator. Always throw out your calculus book. It's all right here. That's all you're going to ever need for calculus. So good luck in your classes, and talk to you later. Have a good one.